Okay, let's look at question number 12, part A of the applied paper, the relative acceleration problem. So this diagram is given. It's a uniform block of mass 10 m, phase containing AE. It lies on the phase containing AE, which is a smooth horizontal floor, so no friction. AB, BC, DE. AB, BC, DE are lines of greater slope of the faces containing them, and CD is parallel to AE, and these three angles are all 60 or pi over 3. Three particles PQR, P is phi m, Q and R are simple m, are held on A, B, B, C, D respectively. The particles P and Q are attached to the ends of a light inextensible string. So that means the accelerations will be the same for both particles P and Q. F1, F1, inextensible, and the tensions are the same. The system is released from rest with the string taut from the position shown in the figure. Obtain equations sufficient to determine acceleration of the block and the magnitude of the reaction on P by the block. Right. So we'll draw the diagram and mark all the forces and the accelerations. Draw a big diagram so that all the angles and forces are clearly seen. C E E. Right. So this is particle P, and then this is particle Q, and here is particle R. Right. Then all these angles are pi over 3. Pi over 3. Okay, now let's mark the forces. Phi mg down, weight, mg down, weight, mg down, weight. Then let's start with the reactions. So normal reaction R1, and then this R1 is on the block, R2, and this R2 is on the block, R3, and this is on the block, R3. Right. And the block weight is 10 mg. Okay. Then tensions. Right. T for both. Right. So right. So when it is at rest, we can decide which direction the block will move using what? R1, R2, and R3. So whether it moves to right or left depends on R1, R2, R3 horizontal components. So when it is at rest, R1 will be equal to what? Phi mg cos theta when it is at rest, and R2 will be mg cos theta, and R3 is also mg cos theta, or this angle is what? Pi over 3. You can, all three angles are pi over 3. These ones are clear. 90, 30, so this is 60. Same thing here. This is why pi over 3. You can extend this line, and this is pi over 3. This triangle is going to be equilateral, no? So then this is pi over 3 using corresponding angles for parallel lines. So then again 30 and pi over 3. And mg cos pi over 3, or let me write it as theta, r1, r2, r3. So then phi mg, all of them are the same type, no? So let me write as phi lambda, lambda, lambda. Mg cos theta is for everything, I will put as lambda. So then r1 horizontal component is to this side, phi lambda sine theta. These two are going to be in the other direction, so 2 lambda sine theta negative. So the horizontal component is to the right. So this should move to the right, the block. So I will label that acceleration as capital F to the right. You don't need to do this part. You can just look at and decide, and it's clear now. This is moving to the right. Just label the acceleration to the right, and then let me take r1 acceleration as f1. This is relative to the block. Q going up f2, then p goes down f2, right? Okay, so let me write this down. Acceleration of the block relative to earth is f to the right. Acceleration of r relative to the block is f1 down, and the angle it makes is 60. A q relative to b, it's going to be in this direction. It makes a 60-degree angle, f2 up, and then apb, that is in this direction, f2 down with a 60-degree angle, right? Now you have to find for p, q, and r the accelerations relative to earth. So acceleration of, it's fine, acceleration of r relative to earth, that is a r b plus a b earth. A r b is that one, 60 f1, and plus f in this direction. So then I will just combine them and use it to get the components in the correct direction. F1 here down, F here, and 60 degrees here, right? Then similarly R A Q E, this A Q B plus A B earth. Q B is this one, 60 degrees, F2 plus F. So then when you combine them, you have something like this, F in this direction, F2 with the angle of 60, right? And finally APE, APB plus ABE. So that will be what? Down F2, down F2 with a 60-degree angle plus F, right? So they are using pi over 3, no, right? I should have used pi over 3 instead of 60. So let me replace this. Radians pi over 3, this is also pi over 3. Pi over 3. Pi over 3. So this will be if in this direction, f2 like that, pi over 3. Right. Okay. Now using these three, we can find the components in the direction we want. Acceleration components relative to Earth. Right. So now, how many unknowns are there? F1, F2, capital F, tension, and R1 we have to find. So five unknowns. No? So I have to give five equations. So the first equation we'll do system to the right. So first equation system F equals ma to the right. So then to the right for the system there's no horizontal forces because our reactions all cancel out, tensions also cancel out. All the other forces are vertical. So F side is 0. Then do mass by mass, the acceleration 10m into F, that is the block, no? Plus then we'll do P. P is what? 5m. What is the acceleration relative to Earth in right direction for P? That is F minus F2 cos pi over 3. F minus F2 cos pi over 3 plus then I will move on to particle Q, which is P m to the right. What is the answer? F minus F2 cos pi over 3 again to the right, the acceleration. F minus F2 cos pi over 3. Then the last one is R. Mass is m. What is the acceleration to the right? Capital F plus F1 cos pi over 3. Capital F plus F1 cos pi over 3. Right. So this is your first equation. Then do three equations for the particles. We'll start with the particle R. F equals ma along the plane down. So for this R, so what is the only component? The weight component, mg sine pi over 3. Mg sine pi over 3 is equal to what? M into acceleration along the plane down. So F1 is along the plane down. F cos pi over 3 component, that is also plus. So simple F1 plus F cos pi over 3. Right, second equation. Then we'll move on to particle Q. F equals ma along the plane up. So what are the forces on particle Q? Tension up, weight component down, mg sine pi over 3 down. So T minus mg sine pi over 3 equal to m times acceleration along the plane. So for Q, F2 is up, we are applying it up, no? So F2 minus, this is also going to be pi over 3. So F2 minus F cos pi over 3. F2 minus F cos pi over 3. That is third equation. Then particle P. F equals ma along the plane down. So this one 5 mg sine pi over 3 down positive and tension is negative. So phi mg sine pi over 3 minus tension equals phi m acceleration component, which is f2 down positive, and this one is again angle pi over 3, so capital F cos pi over 3 negative, so f2 minus f cos pi over 3. So that is equation 4. Right, now we need to write something to find R, reaction R1, the reaction on particle P. So F equals ma to the particle perpendicular to the plane. So first let's look at the forces perpendicular to the plane on particle P. R1 and phi mg cos pi over 3. So I am taking perpendicular to the plane up as positive. So R1 minus phi mg cos pi over 3 equal to phi m. Now acceleration perpendicular to the plane of particle P. So that is going to be what? Let me draw the perpendicular line here. So then F2 you don't get a component because it is what, parallel to the plane, so no perpendicular component. But capital F has a perpendicular component down, right? That is going to be F sine pi over 3, and it is pointing down, right? It is pointing down. Yes, so then I'm taking perpendicular up as positive, so minus F, this one I should write minus F sine pi over 3, right? So this is enough equations. We have 5 equations. Now you can find the acceleration and R1, or the reaction of particle P. So 1 to 5 are sufficient number of equations, right? So those are the equations we need to find the acceleration and reaction of particle P, right? So that is 12 part A. Next we'll do the circular motion part B question.